Okay, guys, so here what we have to do is we have to find what is the force the mover is pulling down the rope. So the mover has to pull with half his weight because there's one force going up, one force going up, and there's one force going down, and that's half of that. So if half of his weight pulls up half of the piano, it'd be 50 kilograms, right? So we use the formula of force. Then this is gravitational pull is G meters squared, right? This will be equal to 490.5. This is the answer 500. The reason is being because of equilibrium, net force, equilibrium is zero. So, okay guys, so here we have a 6 kilogram box in the middle, right? 6 kilogram. We are looking for the magnitude of force T, which is this two, force T going up. Okay, so what we have to do is this is at rest, so acceleration is zero and velocity is zero, right? So net force in the y direction is equal to weight plus A minus T, right? So we have to find the weight, the force of the weight. So the force of the weight is equal to mass times gravity. Gravity is equal to 10. Minus 7 squared. Do 6 kilograms times 10 squared. It gives us 16 newtons. So it's here, back to this equation. Force, where is it? M times A plus FA. Now that is 2T, right? This is 0. A 2T. T equals W plus FA. So we go on to do 2T cosine of 30 because of degrees. 16 newtons plus 40 newtons because of the thing. And then we get 470 for T to be 470 newtons to cosine 30, so give us 271 newtons. So that is the B is the answer. Okay, so in this problem we have a rope fastened to the ceiling with a tension of 59 newtons, which makes this angle here, which is right here, makes that angle with the ceiling, so the ceiling, right? So it's 59 newtons, 59 newtons is making that angle up there, up top, right? So we have a force going that way, force going that way, force going this way, force going up as well. And then we have the horizontal tension being 38 newtons, which is right in here. So it's bouncing forces. So what we do is 59 sine, right, and G. So we have 59 cosine degree 38. So since we have that force, 38, we shall do cosine 38 or 59. That's cosine -1. And then this gives us 49.9, which is 50 degrees. So here we have this problem. This problem consists of a system box comprising light furnishing pulley, furnishing incline, and connector rope showing. 9 kilogram block accelerates downward when the system is released from the rest. So the acceleration of the system is closest to. So we're looking for the acceleration, right? So let's see the work. Oh, sorry guys. What am I doing? So the work is shown here. Mass times gravity. Gravity is obviously 10 again. So we have this first box. There's work going down. Force going to the left. This one's 6. There's D going up. Force going down. And then there's pull up T2. And over here we have T2 again. And the work would be going down. So let's say this is M2, M3 I mean. Let's say this is mass 2 and then this is mass 1. Okay, so what we do is we have each block and multiply them to find each of the works. So block 1, that is 60 newtons, 2 is 40 newtons, 3, 90 newtons. So the first one, 6 grams sine 30 degrees to 30 newtons, and the force 2, which is right there, we're given, it is 4 grams sine 30 degrees, and that is equal to 20 newtons. So lastly, we will have to find the acceleration of it going downwards, right? So that acceleration is given to us as A equals 2.1 meters seconds squared, because we had all the newtons, that is 2.1. Okay guys, so we have to find the mass at the back of the left. What we first have to do is we have to put in the equation yt, eventually to find out t, the y direction plus velocity, the y direction time, that's time plus 1/2 acceleration time squared, which is given to us simplified yt, because we find the acceleration, yo t2, right, times square. So what we must do is we put it in, and we get 0 minus 1 milliliter, because 1 meter down, minus 0t to time square, or 0.53 seconds, that's the time it took square. That gives us -2 or 0.2809, which gives us 7.12 meters per second square. 7.12. So find then net force of y. Y equals work minus t1. So obviously we don't know the first one, so we do the second one, which is 100 kilograms acceleration t squared minus, 1,000, 100 kilograms. I mean 1,000, but it's 1,000 newtons, right? 100 kilograms times 7.12 meters per second squared, which is what we got before. Is negative 712. 1,000 newtons to T equals 288 newtons. So now that we have the acceleration, friction, the time of the second one, we do find the first one. It's 288 newtons over gravity, right, plus the original. It's equal to 16 kilograms. 16 kilograms.